Hey guys, I'm going to teach you how to write net ionic reactions. We are going to be referencing the reaction predictions worksheet that you completed yesterday. So have that nearby. I'm going to go over a couple of slides from the PowerPoint before we get to that worksheet. So keep in mind that you're only going to have to do this for double and single replacement reactions. And you're going to be using a list of solubility rules to figure out which compounds are soluble in water. So make sure you have your solubility rules handy. Those were in your packet. And anything that does not dissolve in water is either going to exist as a solid or a gas. So it will be a precipitate or a gas. So these are your instructions for how to write a net ionic equation. I'm going to go through these rules real quick, these instructions, and then I'll give you some examples. So what you want to do is use your solubility rules to predict whether or not a compound is going to dissolve and split into ions. You'll go through your equation and all of the soluble compounds, you'll go ahead and split them up into their individual ions. And then anything that appears on both sides of the yield sign, so it appears in the reactants and the products side, that is called a spectator ion. Now, in sports, if you are a spectator, you don't actually play the game, you just spectate. You just sit on the bleachers and watch the game happen. So you can sort of think of these spectator ions. They're not taking part in the reaction. They're just kind of hanging out in the solution, watching the reaction happen. So you're going to cancel those out. All the spectator ions will be canceled out because they're not taking part in the reaction. So what you are showing in the end, anything you don't cancel out, that is what's actually changing in this reaction. Okay, so I'm going to flip over now to your worksheet. And this is, I'm just picking up where we left off from yesterday. And I'm going to do the very first one with you. So the first one, we already wrote the equation. Aluminum nitrate plus sodium hydroxide yields aluminum hydroxide and sodium nitrate. All right, and I have my solubility rules nearby. And what I need to predict is whether or not aluminum nitrate is going to dissolve in water. Now, just a quick little lesson on what I mean by that. I'll draw this up in the margin. Sodium chloride. Salt. We all know that table salt dissolves in water. So here's my little beaker of water. If you took table salt and you put it in that water, the way it dissolves is it splits up into sodium ions and chloride ions. And each of those ions is surrounded by water molecules. Remember, water is a very polar molecule, slightly negative charge on the oxygens, slightly positive charge on the hydrogens. So those hydrogens would attract the nearby chloride ions, and that oxygen would attract the nearby sodium ions. So like I said, when sodium chloride dissolves in water, it splits into its ions. Those ions are now surrounded by water molecules, and they arrange themselves so that opposite charges are nearby. So what we're trying to figure out right here is if aluminum nitrate is soluble in water. Will it split into ions when you put it in water? Well, let's look at our solubility rules. And if you look at number 4, it says that all nitrates are soluble. So anytime you see something with nitrate in it, that is a compound that will split. So I'm going to write aluminum as an ion. So we know aluminum has a +3 charge. And I'm going to write nitrate as an ion. Nitrate is -1. All right, now we're going to move on. And real quick side note, notice that I didn't do anything with this subscript here. I'll explain later. At the end of the equation, if nitrate is still around, if we don't end up canceling it out, we'll put that as a coefficient to balance it out. But right now, we're just focusing on the individual aluminum and nitrate ions. We'll balance it later. All right, so when we get to sodium hydroxide, we need to see if this is soluble in water. Well, once again, if you look at your solubility rules, there is a rule that says all group 1 metals are soluble. That's rule number 3. So anytime you see a metal from group 1, that's sodium, lithium, potassium, cesium, etc., those are always soluble. So that means we're going to split sodium into its individual ion and then hydroxide into its individual ion. Notice again, I'm ignoring the coefficient. We'll tend to that later. We're just putting the ions themselves. All right, on the other side of the equation, we need to see if aluminum hydroxide is going to split. So if you look on your list of solubility rules, Rule 8 says that all hydroxides are insoluble except for those with group 1 metals, calcium, barium, and strontium. So keep in mind that insoluble means it does not split. It stays together. Okay, so if all hydroxides are insoluble, these are your exceptions. The one we're looking at is aluminum hydroxide. Aluminum hydroxide is not one of the exceptions, so that means it's going to stay together. It is insoluble. And then lastly, we have sodium nitrate. Remember your rule about nitrates? They are always soluble. And also your rule about group 1 metals. They are always soluble. So this is going to split. Okay, so now we're going to look at spectator ions. Those are ions that appear on both sides of the arrow. So nitrate would be a spectator ion. We're going to cross it out. Nitrate does not take part in this reaction. And then sodium appears on both sides of the arrow. So we're going to cross that out. It does not take part in this reaction. So the only thing actually changing when you add these two chemicals together is aluminum ion bonds with hydroxide ion to form aluminum hydroxide. All we have left to do now is balance our equation. So aluminum is balanced, but you have 3 hydroxides on the right, only 1 on the left. So I'm going to put a coefficient of 3 in front of hydroxide. That also makes our charges balanced. We have +3, -3. So with net ionic equations, not only do you want to make sure the atoms are balanced, but you also want to make sure the charges are balanced. So we are done with number 1. All right, so looking back at our worksheet, we're going to skip number 2. Remember, you're only doing this for single replacement and double replacement reactions, so number 2 does not apply. So we're going to do number 3 now. So we have phosphoric acid plus magnesium hydroxide yields 6 water molecules and magnesium phosphate. Okay, so let's look at phosphoric acid. Let's see if that is going to split. You have a rule about acids, rule number 2. It says if the substance is an acid, only the following are soluble. Now you're going to notice that phosphoric acid is not in the list, so it's not going to split. So that is insoluble. All right, next we get to magnesium hydroxide. Remember your rule number 8. about hydroxides. All hydroxides are insoluble except, and magnesium is not one of your exceptions. So that is also insoluble. So since neither one of our reactants is going to split, that's really all we can do here. So this one, we're not going to be able to split into ions. So we'll move on to number 5. Now number 5 is one of the ones I did not do with you, but you do have the key to this worksheet. Barium chloride plus sodium sulfate. This is a double replacement reaction, so you've got barium sulfate on the right side and sodium chloride. All right, so let's see if barium chloride is going to split. You have a rule about chlorides, rule number 5. It says all chlorides are soluble except silver, mercury, and lead. Well, barium is not on that list, so this is soluble. It is going to split. Barium ion, chloride ion. Next we get to sodium sulfate. Sodium is a group 1 metal, so it will split. All group 1 metals are soluble. Now we're on the other side of our equation. We're looking at barium sulfate. You have a rule about sulfates. It's rule number 6. All sulfates are soluble except, and look what one of your exception is. Barium is on the list. That means barium sulfate is not soluble in water. It will stay together. And then lastly, sodium chloride we know will split because sodium is a group 1 metal. So let's cross out our spectator ions. That's going to be sodium, and that's going to be chloride. And we're left with barium plus sulfate yields barium sulfate, and it's already balanced.